Hi, I'm Rydian. It is now later, so welcome to the second part of the game hacking trainer creation tutorial. So last time we learned about basic scanning and editing values, stuff like scanning for known and unknown values, byte versus float, all that jazz. This time we're going to learn about how to make your codes stick, basically. How to have the codes have some sort of permanence, how to have them work on every run, as opposed to just standard addresses, which are highly unstable. They'll stop working within the same time you're running Terraria, a lot of cases, as you saw with some of them last time. Alright, so as before, you want to have Cheat Engine started up. You're going to want to attach to Terraria. Alright, so we want to make code edits because simply freezing addresses doesn't produce the results you want in a lot of cases. So for example, currently 339 health. For a scan, let's just find the health value. Still regenning, 347. Alright, and 347. So filtered it down, that's got to be the health address. Current HP, set it to 400, and lock it. Alright, there we go. So, like before, this should give, quote-unquote invulnerability. And boop. So we take damage, and it just resets our health immediately. Now, it's just constantly refilling our health, or setting it to the value we wanted. Now, what if we were to take even more damage? Well, let's take a lot of fall damage, and see what happens. Ooh, 766 damage, and we died. Well, why do we die when our health is getting, you can see it happening right here, constantly refilled? Well, we died because our health hit 0, and in this game, when your health hits 0, like in most games, you die. Alright, well, even though our health is getting refilled? Yes, that's because Cheat Engine can't refill our health as rapidly as the game checks it. If you go into the Cheat Engine settings, under the general settings, like I probably showed last time, there's the freeze interval. I have mine at 100 milliseconds just because of some stuff with other games. I believe 250 milliseconds is the default, but don't quote me on that. You could set this down to 1 or something, 1 millisecond or something if you wanted, but I don't recommend it because that can cause potential performance issues with certain things running, and it doesn't really solve the issue to begin with. So, well, what do we want? Well, we want to avoid taking damage in the first place, right? Crap. Oh, those are birds. Thought that was a wraith. Alright, so what we want to do is patch the game code. We want to make a code edit to do that. Alright, so in order to make a code edit to stop us from taking damage, we need to find the code that causes us to take damage in the first place. So once we know our current HP, we can right-click on it and choose Find What Writes to this address. Alright, you're going to become very familiar with this. The first time you do this on a game launch, it'll ask you if you want to attach the debugger to the current process. Say yes. And there we go. There's the logging window, basically. So as our health changes, as our health is modified or written to, stuff should start showing up here, the lines of code. So let's take some damage. Boop. Alright, took some damage there. In fact, there's two things showing up. Well, you see, one of them is happening more or less rapidly than another. Here we have something... There we go, with a count of 1, and that is a subtraction opcode. Well, that must be what subtracted from our health when we took the damage. Here we have some code that ran 20 times already, and that's an increment, which is to add 1. As you see here, as our health regens, the increment code continues to run. So this must be the code that's responsible for regens, whereas this is the code that does direct damage. Alright. Now let's start drowning. Let's go underwater just to show you something. So this code was responsible for, subtracting from our health when we take damage. I happen to know from experience, from testing this game a lot, that this code is done when you take fall damage or monster damage. But you can take damage other ways, and there are other functions that take care of that. So let's start drowning. Have our health subtracted from. Alright, and there something else shows up as we are drowning. Alright. So we'll go up in here, and what is this? Oh, this is an add. Well, why the hell was it adding when our health was going down? Well, let's look over here. Okay, it's adding -2. Why would it do that? Hell if I know. different games, and especially games that rely on, just basically a runtime environment or compiler program or third-party libraries sometimes, something like that, that could be of different versions installed in the system. Different games can, nowadays can have their code compiled in different ways on different systems. So this is like an add of -2, but it might be a subtract of 2 on a different system, which, kind of make more sense, but this is probably getting compiled in this way just due to some quirk in the CPU I have or something like that. So, yeah. Alright, so let's just focus on the subtraction, because that's what damaged us when we took fall damage, and we want to stop that. That's the code we want to modify. We want to make a cheat engine table entry, which, we will take into the trainer eventually, to stop us from taking direct damage. Alright. So let's click stop here, because we don't care about logging anything else, and the logging kind of slows things down. Once you start logging some other things, you'll find that some things are quite slow to log. Alright, so if we click the sub here, this is the subtraction code, you can find some more information here, shows some of the surrounding code, and shows the state of the registers at the time. We don't really care about that view, we want more information and functionality. So with this clicked, we will click Show Disassembler. Alright, and this brings up the memory viewer. If you haven't seen the memory viewer before, the upper half of the memory viewer shows the game's disassembly, or, disassembled output. The bottom half shows the raw memory view. You could be working in one or the other, or both, depending on what's going on. Right now, we're only concerned with the top half. So, when you choose Show Disassembler from the logging window, you will find the memory viewer shows up selected and highlighted on that code. Sub edx plus 0x318 EAX. There we go. Alright, so this is the code. Well, what is this? If you have any sort of background in programming at all, you'll probably understand, quite quite quickly. Sub is an opcode, or a function, sort of, so to speak, kind of the equivalent of calling a language construct in a higher level programming language. So this has two arguments. The first argument in this case is a pointer to the location of our current health. The base address is an EDX, the player base address plus 318 in hex, offset is the current health, and then there's EAX, which is the damage. So subtract from our health the damage that we would take. Alright, well, we want to stop this subtraction from happening. Well, the quickest way to do this, just temporarily as a test, is to right-click this and choose Replace with Code that does nothing. Now, this is a single line, right? It's a single line between the move and compare. So, right-click this, Replace with Code that does nothing. Alright, and it asks us what we ought to name it. We're just going to choose the default. And hey, what the hell? This is now a bunch of lines. What's going on? Alright, well, let's right-click it and choose Restore with Original Code and see what's going on. Well, we need to keep the number of bytes the same when we're working with the, with the assembly or the byte code or something, because, or whatever you call it, because the code that is executed goes in order. It looks at all of these bytes, and actually does the instructions. So we need to keep the same number of bytes when doing it. So this sub is actually made up of multiple bytes. 1 byte, 2 byte, 3 bytes, 4 bytes, 5 bytes, 6 bytes. Right-click it, replace with code that does nothing, and it's 6 lines. 6 single byte instructions. This is NOP, or no operation, which tells the computer to do nothing. NOP could be either NOP or NOOP, just depending on various things, depending on who's saying it or what program is showing it, basically. Or it could be in, different architectures or different disassemblers and stuff like that. Alright, so with this code NOP, the subtraction theoretically no longer exists. So let's try taking a bunch of damage. In fact, let's try taking all the damage. Fall down, take a bunch of damage, there we go. 762 damage taken, and we're still fine, because the game is no longer subtracting it from our health. Well, there we go. That's already immediately better than just locking the address, because we can take any amount of direct damage, and it will not actually be subtracted from our health. So that's pretty much immunity to damage. However, this is sort of a roundabout way of doing it. and we had to find the address manually. We had to log it until we got damage, we had to show the disassembler, we had to look at the code, and we had to right-click it to remove it. Well, we don't want to do that every time, and you can't really release a cheat table with that because there's nothing really saved in here other than the address, which doesn't want to work, after some time. So how do we get around this? How do we make some code or some sort of script or function in the cheat table that will do this for us automatically? Thankfully, Cheat Engine has various tools to allow you to set that up rather quickly. Alright, so what we're going to want to do is, with this code selected, and by the way, if you scroll and miss and stuff, you can actually just click the code and show Disassembler again, it'll jump right back to it. With this selected, we want to go to Tools, Auto Assemble, or with it selected, you can just hit Control A. It's best if you have the right code selected before you do this. So choosing that option will bring up a new window. This is the Auto Assemble window. This is basically the AA script creation window. This has a couple of neat little templates for us right here that will work off of our selected code. First thing we're going to want to do is go to Template Cheat Table Framework Code. This will insert an enable and a disable section. This is so that when we add this to our cheat table as a script, it can be toggled on and off. Next thing we're going to want to go to is Template AOB Injection. Now, I could show you something simpler with a code injection, but really, I don't want to show you, shorter methods that you all might take that won't accomplish the intended task. So while for other games and other cases you may use code injection, here we want to use AOB injection. Which, by the way, make sure you're using a recent version of Cheat Engine, like 6.4 or later. If you're using some other older build, then just update so that you have this option. Alright, so we choose AOB injection. The first thing it's going to choose, or the first thing it's going to want us to choose is which address we want the jump on. Now this address right here actually represents this. Well, let's just cancel this and look at this for a second. That didn't look like that at all. Why is this displaying as Terraria player hurt? Well, that's because I have view show symbols checked. If I didn't, we'd see an address there. And if we go to template AOB injection, it by default assumes that the address highlighted is the one that we want to do. So in order to avoid having to change this, it's why I recommend having it selected before you open the auto assemble window, because it bases it off of what's selected there. Alright, now we have this, right? With show symbols on, it shows us the actual name of the function. That's useful, right? Of course, we figured out what the function was doing just by testing and looking at, the actual opcode of the function itself. However, in games like Terraria that are written in .NET, because Cheat Engine has the .NET data collector running nowadays, so it can actually gather additional info about .NET games, including the function names, structures, stuff like that, which is very useful. However, I didn't mention this before because this won't always exist. It only works on .NET games and mono games and stuff like that. So otherwise, we just pretend that this doesn't exist. But hey, for Terraria, it makes testing and figuring out what's doing what really easy, because you can just click over here and find out what's what. In fact, if we go over here, click, what's this increment in? Oh, well, it's in the Terraria player update life regen function. Okay, what's this add? Terraria player check drowning. Alright, well, we knew those to begin with, but right here the game confirms it for us. And when you're dealing with more complex concepts in games, especially .NET games, knowing the name of the function can really help. Alright, let's go back to the sub here. Go back to the auto assemble window. Template AOB injection. So we know that that address is correct because it's a selected one. We saw that it was correct, so we'll hit OK. Now what's going on? There we go. Why did it pause? Because it's doing AOB scans to try to find a proper signature for itself. Alright, I'll show you about that in a second. Now it's asking us a name for the symbol for the injection point, sort of what this code is going to be referenced by in name, sort of like giving it a variable name. Now, you can just name it the default of inject, and if you do, you're a lazy dumbass and you're going to run into issues. It takes a couple of seconds to give it a unique name. Please just give it a unique name. It will save you headache in the future. Alright, because later on, if you have multiple scripts and you want to combine them into one, but they all reference different places with the same injection point, you're going to run into issues. So you're going to want to give each code a unique name. Now, we're going to name the injection point, name this code. We could name it like Terraria Player Hurt or something like that, but let's just go with a standard naming convention I like to use and say like do direct damage. So let's just call this code do direct damage. We'll hit OK, and bam! Lots of stuff gets automatically inserted for us. Well, wow, this is a lot of crap. Okay, let's clean it up. Let's remove this comment section. Let's remove these blank new lines, and let's go down here. Now, this is a commented disassembly of what we see there. This is automatically inserted here, for example, if somebody else looks at your code, or if you go back later, this is basically an example of what you were targeting and modifying. We don't need that for now, and I'm just going to remove it just because it's visual clutter for this tutorial. You may find in various scripts I leave it in because it is helpful, but for this tutorial it's just clutter. Alright. So here's the enable section, and this is all what happens when the code is enabled, and here's the disable section, which is what happens when the code is disabled. Alright, so what happens when the code is enabled? Well, let's run over this. So first of all, it does an AOB scan, which is an array of byte scan. So AOB scan, here's the function name, new direct damage, or sorry, our sort of name for that point there, the label, and here's a bunch of bytes. Well, what is this? Where did this come from? Where did you go, Cotton Eye Joe? No. If we were to look over here at the bytes, we'll notice that this matches. In fact, these match this exactly. 298218030000, 298218030000, and then where's the 837D? Well, that's the beginning of the next opcode. Alright, well, that's a specific pattern of bytes. In fact, if I right-click this, choose Go to Address, and then copy the current address, then go down here to the memory, the memory viewer, and paste it. We can see right here, this is the game code we're looking at, 2982180300008337D. So this is that signature. This is that collection of bytes in RAM. So what this is telling the game to do is, alright, if you were to use the basic code injection template, the cheat engine would try to target this exact specific line of code. Well, it doesn't go by the code itself, it goes by the location. And things can change, things can be different. The game could be updated and some stuff could be shuffled around. .NET could get updated and some stuff could be shuffled around because, earlier opcodes could be compiled to different things, like we see here. This is adding -2, but you could also subtract 2. Stuff like that. Stuff might get shuffled around. So that's why the code injection works for a lot of other games, but not specifically for games that compile on demand like Terraria and some other newer games. So this searches for this specific byte pattern and then targets the location that this byte pattern is at in the current run. Okay, so that means this should always find this code. The game developed this signature itself by doing various AOB scans between the part where we named the address and where we actually named the injection point, and that's why it took a couple moments, because it was doing various AOB scans to try to find one that was unique, try to find what would target this code and only this code. If your signature is incorrect somehow, you could get no results, or you could get multiple results and end up modifying the wrong code and causing all sorts of issues. However, the auto-injection template takes care of that for you, and it generally does it well enough. In fact, it'll back up and use offsets if needed, if you all know what that is. Alright, anyways. So this scan, does do direct damage, and then it allocates some new memory. Then it applies a label for code and a return label. Now, new mem here is where you can insert, a block of your own custom assembly that could be jumped to optionally. We won't be touching this. Code here is a copy of the original code. Well, hey, look, that looks familiar. Sub EDX318EAX, that's that right there. So this is the copy of the original code, and this is what we want to modify. and then it jumps, jumps return. So basically, when you execute this script, which we don't want to click the execute, by the way, when you toggle this script on from the cheat table, it will overwrite this subtraction code with a jump to some new code, and it'll run our copy of the code instead, which we can modify as we see fit. Continuing on, do direct damage, this replaces with a jump. I'll show you what that means. And the disable, blah blah blah, reset stuff to default, unregisters, blah blah. Alright, we don't want to click this execute button, because that will make the changes to the game as it is, and as far as I know, there's no easy way to undo that. You don't want to do that. Avoid this button under normal circumstances. You want to go to File, Assign to Current Cheat Table. Boop. There we go. There's the script. Now we want to close this copy. Let's rename this. We want it to cause no direct damage, so let's just name it no direct damage. And we can double click it to open it up again. And here it's the execute is replaced with OK to save the script. Alright. Now let's see what happens when we turn this script on. Right now we have this subtraction code. Well, what happens to it when we turn this script on? Because we kept the subtraction code, we didn't actually modify the script, it doesn't do anything useful yet. Well, let's just see what the template causes to happen. We check it, it does the scan for a second, and then bam, oh well, what's this? It replaced it, but it replaced it with a jump and then a nop so that it keeps the same number of bytes. Well, we can see here it actually applied the label here as well. Well, what is this jump? Jump tells the execution of the program to jump to a specific other part. So you can follow these by pressing space. So when this is highlighted, press space once, and you'll follow the jump. Well, what is this? Well, this is a bunch of unallocated memory followed by newly allocated memory that Cheat Engine set up when we toggle the script. Alright, so it jumps over here where it contains the copy of the code, and then what's this? A jump back, which if we follow, jumps right to the end. So that's how these injection scripts and injection templates work. The default code injection template does the same thing, but the default code injection template doesn't use AOB scans, so that's why we're not using that. Alright, so well, this is nice and easy. So when we toggle the script on, it jumps over to some new memory, which executes whatever our modified version of the code is, and then jumps back as if nothing changed. Well, let's uncheck this to restore things to default, and now let's actually edit the script. So you see here, this is a subtraction. Well, let's just not have this added in. We can delete this, or we can comment it out. I prefer to comment it out so that you can see easily what it was if the section down here is missing, and it's easier to copy out of this anyways. So let's just keep this commented out so that it doesn't add it back in. Alright, well, now we check this. After scanning, it inserts the jump, which jumps over here, which immediately jumps back, so it doesn't even execute anything because we removed that. So with this no direct damage script enabled, we should not take damage. See, there we go. So same sort of effect as just right-clicking it and choosing to replace with a code that does nothing. However, this version will work. If we were to save this table right now, the current HP address would be completely unusable the next time we loaded up the game in the table, but the no direct damage cheat would stay. So there we go. Now we have a quote-unquote permanent code. If the game updates, the code might need to be updated and stuff like that, but there we go. There's the first code that does no direct damage. See, it's off and we take damage. Now, what if we want to change it in other ways? We can do that. So it's disabled right now. Let's double-click it. How about we change the sub to an add, which is a similar opcode, takes the same arguments. However, instead of subtracting, from our health the damage amount, it will add to our health the damage amount. Changing the sub to an add is simple because they accept the same sort of arguments. Let's OK to save the script. Check it to, have it injected again. Let's follow the jump. Yep, it inserted an add. Let's jump back. So theoretically, this should add to our health when we take damage instead. Oop. There we go. I quote-unquote took 66 damage, and it gave me 66 HP, because instead of subtracting from health, it's adding to health. Boop. There we go. So that's something a little neat and fun. So you can see that in addition to removing or, knopping existing opcodes or functions, you can modify them as you see fit. And in fact, since injection templates allocate some new memory, we can actually insert a bunch of new addresses here. Whereas if we were just doing this manually, we couldn't because there's no room. So that's why that's why it jumps over to new memory that has a bunch of extra spare room in it. Alright, so let's just keep this commented out for now. So there we go, that is our first code. That is the no direct damage code. Alright, what about other stuff? What about mana? Well, there's 260 mana there, so let's find our mana value. 260, new scan, first scan. We're basically done with this, so let's close this logging window in the memory viewer so we can see our mana more. Now let's start using our mana. Alright, so I used it and then quickly, tabbed out so it wouldn't regen, so our current mana should be 200. 200 next scan to filter it down. There we go, that's gotta be our mana address. Current MP. Alright. So let's just watch that. If we were to lock that, yep, that looks good to me. Now, of course, like with the health address, this will change and this won't always work. Alright, well, let's do the same thing. Right-click, find what writes to this address. We already have the debugger attached, so it won't ask us another time. Hey, what's this? Move? What's this doing? Well, let's click Show Disassembler and find out. Update mana regen. Okay, so apparently the game consistently tries to regen our mana even when it's at full. That seems a little wasteful, but that's just how Terraria works. Now let's actually use some mana. Oh hey, there we go, there's the subtractions. Every time I fire off this weapon, we get a subtraction because it's using mana. Alright, well, let's just stop the logging for now. Click Show Disassembler. So, Terraria player item check. Well, this is a subtraction. Alright, well, we want to change this. So, with this selected, go to Tools, Auto Assemble, Template, Cheat Table Framework Code, Template Aob Injection, Default Address, because it's the one we have highlighted. It'll do some AOB scans to try to make a good signature. Alright, what do we name it? Subtract MP. Subtract MP. Let's just name it that. Cool. Okay. Alright, there's our there's the template here. Here's the sub. Under the code section, let's just comment that out and avoid this dreaded button. We'll go to File, Assign to Current Cheat Table, close this copy, name it No MP Loss, check it. Come on. You can do it, game. There we go. And, there we go. Inserted the injection, which doesn't have our copy. This is sort of a lazy way to do it. Doing byte replacement would be cleaner, but also more effort. And I've got a thread in the forum showing how to do it manually anyways. Alright, so this item should no longer subtract MP when we use it. And there we go. The bar doesn't flicker. If we were to just lock MP, you'd see the bar flickers, because it's just resetting our MP. However, if we use the no MP loss script instead... Now, here's the thing about AOB scripts in large, kind of RAM-heavy games like Terraria. Look at this. 3/4 of a gig for this. It can take a couple moments to scan for the game code, especially because if we go to View, Show Symbols, we can find that this is sort of high in the game's memory. View, Show Symbols again. For various other games, AOB scans are a lot faster because various other games keep their loaded game code rather low in memory. Alright, so see here, there we go, we have infinite MP, right? Well, what about this weapon? Hey, wait, what? Our MP is still being regened by this weapon. Well, why is that? I thought we had infinite MP. We patched the function that subtracted from our MP. What's going on? Alright, let's right-click our current MP value and choose Find What Writes to This Address again. Bring up the logging window. Alright, so after we've regen, let's use the Demonic Nebula Blaze I've got. Alright, so nothing's happening. How come nothing's showing up in the logging window? because nothing's subtracting from our MP because our no MP loss script is activated. So let's uncheck that, and then we will see the code actually being executed when we subtract from our MP. Alright, well that's the code that was patched. Well, what does the last prism do? Does that do anything different? Oh, it does! As you see here, there's a separate sub-address for this type of weapon. Specifically for weapons that drain mana over time have a different subtraction address. Alright, well, so this one, the one for, standard mana regen on, or standard mana loss on use, is Terraria player item check plus 1b27. What's this one? Oh, Terraria player check mana. Okay, that's strange. This is a different function. Well, if we wanted to have infinite mana for both weapons, we could make two different scripts to patch both of these functions. So, no MP loss for direct and no MP loss for drain. Or we could combine those two into a single script by copy-pasting segments and stuff like that and rearranging them properly in the auto-assemble window. But that seems a little messy. So instead, why don't we get infinite MP a different way? So let me just close these. Alright, so let's think about this logically. We want to have different MP. We want to have infinite MP, so we need to patch a different function, a different type of function. So how about instead of changing what writes to our mana, how about we change what reads our mana to try to fake the fact that we have full mana, or try to tell it to regen our mana when it reads it. Alright, let's do current MP and choose find what accesses this address instead this time. It'll bring up a window and hey, there's stuff already. As we move around, ooh, this is laggy as hell. In fact, if we go back here, there's a lot of stuff constantly logging. Let's click stop. So this is one example. You can see there's tons of functions that are reading from your MP, and I didn't even fire off any spells. If I were to fire off any spells, we'd see a lot more show up. As you can see here, this is one reason you don't want the logging thing always running, because it can be rather laggy, and a reason that a lot of people choose writes instead of accesses, because accesses can be pretty laggy, and will get what writes as well. Accesses will get reads and writes. Writes will only get writes. And most of the time you're only going to want writes. But in this case we want to find what access is because we want to fake having full mana by finding what reads our mana and modifying that, which is slightly more advanced than the previous things we were doing. Alright, well, what the hell's any of this? Well, we could experiment with these, or since this is Terraria, and this is a tutorial on showing you the quickest, easiest way to do this crap, show disassembler and look. Terraria main GUI bars draw inner. Well, this is probably the function that reads your current mana in order to draw the bar. Alright, what's this? Terraria player update. Terraria player update mana regen. Update mana regen. Update mana regen. Update mana regen. What about these? Update, Terraria player update. Well, let's do this one. Now, if you look at the counts, this code is executed the most, and this is what reads from our current mana to draw the bars. So if we want our mana to be refilled the quickest, we're going to want to target the function that's executed the most often. Alright, depending on the kind of hack you're trying and the game, this could vary. You may want something that's written more rarely, or something that's written, pretty rarely, depending on what's going on. But for now, we want our mana constantly refilled, so we'll focus on this function. Alright, so with this selected, this is a move. What is it doing? Well, it's moving what appears to be the pointer to our current mana into some other variable or another register, which it then does other things with. Alright, well this is what loads our current mana. So with this selected, Tools, Auto-Assemble, Template, Cheat Table Framework Code, Template AOB Injection, Default Address, and we will name this one Read Mana. Click OK. There's the injection template. Get rid of this. File, assign to current cheat table. Close the copy. Rename this. Read infinite mana, I guess? Read infinite MP, whatever. Now let's double click to modify it. So here's the original code. This reads the current mana into some other stuff in order to draw the mana bars. We don't want to get rid of that. We like that. We like it drawing the mana bars. We want it to also regen our mana. So, since this is an injection template and it's inserting some new code, we can add stuff. We can add stuff before or after this. Alright, now, how would we modify what's going on here? How do we know what to do here? How do we know how to modify the assembly? Well, move takes the form of destination source. So for example, move into EDX the contents of our current mana. Well, this represents the contents of our current mana, right? So let's copy this and make a new move statement. So how about right after it reads our current mana, we will say move this. So move into our current mana. What do we want to move? Well, how about we want to move full mana into our current? Alright. Well, 260 mana is our full, so let's just say we're inexperienced and we go ahead and type 260 here, which is functional, but not exactly what we want. So let's just add a comment, overwrite current mana with max, so that we know from a glance that this is some new function. Well, let's go OK, let's click it, wait for it to scan and patch. Alright, now what do we have here? Wait. What the crap is this? 608 mana, but we told it 260. Well, let's test it. And hey, infinite mana. And it works with both weapons. So there's one code, infinite mana, that should work with anything that uses mana. But why the hell is it 608 instead of 260? Well, here's the thing. Let's uncheck this, go back and look at the script. This is... Alright, auto-assemble. The auto-assemble window uses auto-assembly, which is where we insert assembly. And we put this number here, and there's these other numbers here. Well, look, some examples. Why is an E there in this number? Because this is hexadecimal instead of decimal. Now, let's fire up the Windows calculator, and if we go to View Programmer, there's hexadecimal and decimal modes. So we want to tell it the hexadecimal representation of 260. Alright, well, in decimal mode, we'll type in 260, then we'll click hex. Okay, 104. Alright, so if we tell it 104, and then we check the script again, so it's inserting the hex value of 104, there we go, that's 260 exactly. So we can just do this. Now, what if we don't want to do hex calculations like that? Well, thankfully, AutoAssembly has little type flags. Let's say if we wanted to make the MP 999 just in case. Alright, 999, but that's in hexadecimal. Well, let's just say int here. This tells, this little open parentheses int close parentheses tells AutoAssembly that we want the integer representation of this, which is a standard decimal, thing we're used to, instead of hexadecimal. So let's click OK, check the box, look at our mana, 999 out of 260. So no matter someone's max mana, this should work for them. So there we go. Infinite mana with various types of weapons. So there we go. We took something that reads from our mana and we inserted a write. We made use of the injection template so that we could add the additional code that we wanted. So now we have 3 codes. Let's just move these addresses up here. No direct damage, no MP loss, and read infinite MP. Or let's just rename this to infinite MP because effectively that's what it does. So there we go. There's 3 scripts there. If we were to save this table and distribute it later, these 3 scripts would continue to work because they scan for the game code, and when they find the game code, they patch the game code or, inject what we want there. So as long as Terraria and .NET don't update, this will work across successive launches, just like you want them to, even though addresses don't, the scripts do work, and you could distribute this table to other people, and assuming they're using the same Terraria and .NET version and all that jazz, this will work for them as well. And this is the exact same type of thing I have in the trainer. The trainer is just a collection of scripts like this. I mean, not exactly like this, but you know what I mean. same template, same sort of modifications and stuff like that. So it has different scripts, but I use the exact same process. I find a value, I find what writes or reads to that value, and then I use I use an injection template to modify it, sometimes doing things by hand if it's more complex. Alright? So there you go. That's how you make basic AOBs and scripts, it's how you modify writes, it's how you modify reads. So far we've only messed with basic integer values and stuff like that, and we've only done minor modifications. Next time we will get into more advanced custom code and scripts and working with floating point values such as for wings and stuff. Alright, I'll see you next time.